to show you how to send data from our Siemens S7 PlC to the PC. As you can see here, we have a PLC 1200 Siemens Simatic S7 1200, which is connected via the TCP port to our PC. And we have two potentiometers, this one, that are connected to the analog entries, to the two analog entries of our PLC. And we're going to try to read from our PC the values of these two potentiometers. We also have this normally off button over here, which is connected to the digital entry, to the first digital entry, I0.0. And this button is going to trigger the communications to our PC. Alright, the first thing we need to check is the IP address of our PC. Ethernet, in this case, this one is our card that is connected to the PLC. We go here to properties and TCP IP version 4. We go to properties again, and here you can see I have manually set up the IP address of my PC in 192.168.0.30, and we will create a new project. We now go to the project view, factory settings. So now we go to add new device on our project. We're gonna set an S7 1200. In this case we have a 1212 CDC relay, and we have this one over here, the HA40 0xB0. Okay, alright, now we double click on our PLC and we check up. You should have here on the access level full access, no protection, in order to be able to read and write to the PLC. So for now, this is the configuration of the PLC. We can now go to the program. We go to our program blocks, main block, and the first thing we're going to do is we are going to add a new data block. Data block, okay. We're going to set some variables. We add here a temporary integer variable, data type integer, which we're going to use later on. Temporary real variable, in this case data type will be real, and for the transfer we're going to use a variable called data, which is going to be a string. This is it for now. So the first thing we're going to do is we're going to read our analogic input. Move from our entry IW64, which is our first potentiometer. We will move it to our temporary integer variable on data block 1, temporary integer. Next thing we are going to, we click here on conversion, we normalize. So our entry from data block 1 temporary integer is going to be between 0 and, in our case, because of the values that the potentiometer is giving on the voltage, it will be, we will set 24,570, and we move it to our data block temporary real. So here we have our normalized value, and now we scale it. We scale it data block temporary real from 0 to 100. And we store it. Sorry, here let's go back to a data block. Let's make a new row, which we're going it's going to be analog values, and this is going to be an array from 0 to 1 of integers All right, so we're gonna store the data in the analog value 0 for our first potentiometer. And now again, let's copy all this here to a next branch, and in this case we're going to move IW66 to a temporary integer. From there we normalize to our temporary real, and from the temporary real we store it in our data block analog value 1. Okay, so now we should be okay for reading the values from our PLC. So now what we need to do is we need to set up the data to be sent. Set data to send. In this case, we will use our normally off button here, which is I0.0, to send the information. So when we press it and we check a pulse here on this button, 0.0, we will, first of all, we will move in this case a space, and I will show you later why we start with the space. We move to our data block data variable, we take out the brackets, so we start by moving one space in order to make a space with the first characters that are being sent in our communication block. So now the second thing is we're going to convert our value, our analog value 0, which is the first potentiometer, We're gonna put it into a string. Let's go back to our data block now. Let's create here a new variable. We would call it parameter, and it's a string in this case. So we convert our integer value from the analog entry to our string variable parameter. Take off the brackets, and from there we will concatenate. So we use now, here we go to our extended instructions, to the string and character instructions, and we concatenate here over here. So to our data block, our data string, we will add now that data block parameter, and we will put that on our data block data without the brackets. So as the first thing. Second thing, we will move. Now we copy this again in a new branch, and in this case we will use analog value 1, and we concatenate it to our data block. So for now this is it. So the next thing we're going to do is we are going to set up the communication block. In order to do that, let's create a new function. Here we click add a new block, a function, OK. And in this function, we are going to use a tsense instruction, which is on the communication part, open user communication, and here we have the tsense. Set up here the tsense be OK, the data block for this instruction, and we click here to start configuration. Okay, in the configuration here we set up the partner to be unspecified in this case. Connection data, we're going to create a new block for the connection data, which is PLC1 SendDB. Over here you can see connection type is TCP, connection ID is 1, and it's active connection establishment from our client, which in this case is going to be the PLC, and the server is going to be our PC. So we will send it to our PC, which is on IP address 192.168.0.30, and we are going to use the port 2000, which we know down now for later on for our PC program. Okay, so now in the system blocks, program resources, we have the tsense DV here block. This data block, we open it. Let's undock it, and here you can see it has created a lot of variables to control our communication. So in this case we will set up request. In the request field, con variable in connect. For data, we're going to use our data block. Let's close this one and we undock this one. So our data here, where we are storing all our parameters, is what we are going to send. We close now our data block and we go back to our TSENCDB. We undock it, and over here now done is done. BC error to error, and status to status over here. Okay, so basically we are going to use the request variable to start to send data. So whenever we send that variable to true, so to value 1, it will send the data. Const will mean to make the connection. So when we change this value to true, it will set up the connection. We will do that at the very beginning. The data is the data we're sending, and here for controlling our communication, done will be true when it's done. PC will be true when it's sending the data. Error will become true when there's an error, and the status will be filled out. If you go to help here on the TSNC, you can check all the values, all the different values of the status of the communication. So that's basically our function block, which is going to be sending the data. If we go back to our main block, now we can just drag and drop our function over here. So every time our program goes to here, it will try to send the information whenever, remember, the request over here, the request variable is set to 1. So now we have to, on our main block up here, we have to do two things. The first thing will be to set, so we will check if our over here, if data block if TSENCDB con is not set, we will set it. So over here we set our TSENCDB cont. So if cont is not set, we will set it to 1, and by doing this we will start up the communication. So next thing, when we press I0.0, this normally off button, we move our reading from the analog entries to our data block, and now we need to activate our TSENCDB request. So we put that one to 1, and it will automatically send the data in FC1. So this is it for the PLC program. Let's save it and downloaded to the device. Data blocks, reinitialize. Oops, we have an error, compilation error. Yes, we have used a move. Move block function, and it's not move, it's s move here, s move. So a string move, we move space to our data block 1 data. Alright, and here again it's not a convert, but it's a string convert. So it's data block 1 analog value 0. We move it to data block 1 parameter. Alright, so take this convert off, and again this is not convert, but it's an S convert that we will put in here. Analog value 1. Alright, so this is it. We should be good to go now. Initialize, load, successfully compiled, and it's downloading the program to our PLC. Right now, let's write our program to read the data from our PLC. In this case, we're going to use a Java program. So we're going to write directly in our main method from our main class. We're going to write the program to read the data. In this case, we are going to embrace everything into a try-catch with an IO exception. Which in case it fails, we will just print out our error, system out, print communication error plus E. Alright. So inside our try port, we'll start defining our server socket. Server socket equals the new server socket, and here we will use port 2000, which is the port we set in our PLC. Now we open our socket, so socket equals to server socket accept. Using this command, we are opening the socket, and let's here print out connected to PLC. Alright, so now we will create our string reader. Our string reader, input string reader, let's call it input string reader equals to new input string reader of our socket get input stream. Now let's declare a variable to read the characters we're going to get. So, read equals 0. This is going to be reading our characters from our buffer. So now we enter into an infinitive while true loop, and here we are going to the string builder. We're going to declare a new string. So data equals to new string builder. And here what we do is read equals data dot read equals input stream dot read. So input stream, this has to be different than 0. So while we are reading from our communication port, so while there is data, what we are going to do here is we're going to append to our string builder data append so here we're going to cast our char character from our read variable. If data is not null and data the toString data toString equals, so if it's not null and it's not empty, let's negate it here. If data is not null and data is not empty, then we will generate our parameters from in a string array. Let's call it parameters equals to data dot to string, so that's the string part of the data, and we're going to split it with spaces. So every time we see a space, we're going to split it into a new parameter. that's our data, and now let's just print it out. So system out print, and now let's say parameter plus, let's do for integer I equals 0, I is less than parameters dot length add 1 to I. So in this do for, we're going to print each one of the parameters. So we'll print parameter plus I plus equals 2 plus parameters I. Alright, so basically this is our program. Let's run it at our PLC so you can see what is going on. So now let's run this. Okay, it's running. Connection has been made to the PLC now, and let's press our normally off button. Here you go. So once we press the button, you can see there has been 3 parameters. The first one is made out of the first 2 characters that are being sent by the PLC in order to set up the TCP protocol, so it's not relevant for us. In the first parameter, we have our first potentiometer value, and in the second parameter, we have our second potentiometer value. Now you see that if I change my potentiometers and I try again to send the data, you can see that now data has changed and it's 8457. Each time I press, the values are coming into my PC. So basically that's it. Thank you.